I've built up a simple LC filter right here, and in this video I'm just going to show you how I go about testing this filter. Okay, so here's the setup. I have a probe here, scope probe, and I've labeled these channel 1 and channel 2. And channel 1 is probing the output of this board here. It's a SI5351. You can see the frequency there. It's a clock generator board, so it's supposed to spit out square waves, but it doesn't usually end up that way. And I'm using this because that died. And this is being controlled by an Arduino Pro Mini, which is just doing a sweep of frequencies from, I think it's 5 megahertz to 15 megahertz. And channel 2 is probing the output right here of the filter. Okay, we're looking at channel 1 right now, which is probing the output of the board directly without any load connected to it. And the important thing to note here is that the amplitude of the wave is roughly constant as we sweep through the frequency range of 5 to 15 megahertz. And right now our scope probe is on 10x, and you can see that it starts off as a square wave and then goes out and turns into something not a square wave. So in this whole test I might just switch it back into 1x so it looks a little bit prettier. I know this might not be the best practice, but this way I can see the tips of my wave and I could use that to kind of gauge where the amplitude is. This is slowly just kind of scanning and sweeping through the frequency range, and I have the cursor set at roughly the 40 meter frequency, so it's just kind of a reference. Up at the computer, you can see that I have the frequencies being printed out, and it's just scrolling past as it sets the board to that frequency. And another feature that I've put on this thing is a little button here, so when I press it, the board back there lights up, and the frequency stops scanning, so it just kind of pauses it, and when I release this, that will continue the scan. This program is ELSIE, E-L-S-I-E, and it's a free program for analyzing filters. And I have it drawn out a little bit bigger here, and you can see that it's only 2 capacitors and an inductor, and that's about it. So the frequency, you can see down here, this is 5 megahertz, that's 10, and 5, 6, 7, so this is 7 megahertz, which is kind of where I want. And up here, you can see that it's already starting to roll off here, but these are calculated results, and I'm not going to be trusting these too much. So you can see that this is right around 7 megahertz. You're at minus maybe 3 or 4 dB, right? So we'll see how this works out on the actual test results. Okay, so now I've got both channels on and it's just looking like a mess. So I'm going to go ahead and turn channel 1 off, and now we're looking at only the output of our filter. And you can notice that this goes up, way up, and then back down, and I've set that maximum point to roughly the entire width of the screen, and we're at less than 200 millivolts per division. And at the highest point next sweep, I'm going to stop this and check out what frequency it is. So I'm going to get ready, and here it goes. Stop. Just right about there is maximum, okay? And you can see that we're at 7.45 megahertz. So this frequency response is pretty awesome, and if you let it go, we're about halfway down, right? This is about 3 dB down, and we're at 8 and a bit megahertz. So this tells you that this filter for 40 meter might be a good filter. Okay. And does this match with our computed data? Well, you can take a look over here, and 8 megahertz is this line right here. So it's 5, 6, 7, 8, right? So that's this one. If you look straight up, you know, that says minus maybe 3 or 4 dB, so I think that's pretty close on this thing. But the frequency response down here kind of is different in our test results. Our test setup, it kind of goes up and then back down, where this just shows a flat line all the way on top. So nothing's perfect, and there's usually aren't flat lines anywhere in homebrew gear. So yeah, it kind of goes up right around there and comes back down. And we can take a look at when it goes up by waiting for this next sweep. And about I'm gonna stop this sweep while it's going up. So right about there, that's kind of like halfway to maximum value, and we're at 6 and a bit megahertz, right? So this is actually designed to be a low-pass filter, but I guess it's sort of a bandpass filter also for 40 meters, which is quite interesting, and that's good for us. So that was a quick demonstration of this setup and me testing a filter out. Maybe there are better solutions out there for testing filters, but this is what I've got so far. If any one of you have different ideas, feel free to toss them in the comments. Thanks for watching, and I'll see you next time.